Hello class. I've got some new notes to share with you. This is all chapter 4 content. It has to do with dilutions and conversions of volume to number of moles to volume, and all the other possible permutations of that formula. So I'm just going to show it to you. And what you can do is pause the video and copy the notes if you like, since we don't have a way of, suppose I could scan them all and send them to you. It's a lot of trouble getting all your emails. If you put it on TV, you can see it quite clearly. I tested it yesterday. So just pause it every point. You'll be able to read it. Just stop at page 3. Here's the second half of page 3. Top half of page 4. Second half of page 4. Top half of page 5. Second half of page 5. Top half of page 6. Second half of page 6 of my notes. I'm going to put this all on the little board, or maybe a good part of it anyway, and I'll explain all of it. Top half of page 7. Bottom half of page 7. Top half of page 8. Bottom half of page 8. And I'm just starting page 9 of the notes. So you're up to date with the notes. If you want, you can copy all that into your notebooks. Where I left off was working with the redox. I did some examples of redox. I showed you the activity series and how to use it to predict the outcome of a single displacement reaction. The next thing we're going to look at is the concentration of solutions. It's on page 147 of chapter 4. I know you guys don't have the textbook, so don't worry about it because I'm going to do it all on the board. So what is concentration of solutions? It is a measure of how much solute you have dissolved in a solution. By definition, concentration of solutions is the amount of solute dissolved in a given quantity of solution. So molarity is defined as moles of solute divided by liters of solution. Or you can say big M equals N over V, where molarity is M, moles of solute is N, and the V is liters of the solution. Remember, you can use your math skills to rearrange the equation to give you the following as well. Okay, so you can transpose those variables around to give you all the different combinations that are useful to your calculations. You should be aware that when a salt with multiple copies of the same ion within the salt is dissolved in water, you get a higher concentration of that given ion. I'll do an example of that later, but first let's do a practice example on page 147 where we use this new formula. The question asks, what is the molar concentration? No, sorry, calculate the molarity of a solution made by dissolving 5 grams of glucose, C6H12O6, in sufficient water to form exactly 100 milliliters of solution. So you have 5 grams of glucose. So let's find the molar mass of glucose. So it's going to be 6 times the 12.011 plus 12 times the 1.00794 plus 6 times the 15.394. So that gives you 5.0 grams over 180.15768 grams per mole, or 0.277 53465 moles of C6H12O6. But recall that a molarity is equal to the number of moles divided by the volume of the solution. So you have this number, 0.0277, etc., divided by 0.1 of a liter, because that's what 100 milliliters equals. So your final molarity after sig figs, and I can't show you the actual number I got, but it's this, where the decimal's been shifted over by 1. So you get 0.278 when you report it to the correct number of sig figs. That is the molarity of your solution. I really must remember to turn off notices on WhatsApp when I'm teaching this class, because I keep on getting banners. Rather annoying. Who's watching, by the way? I only see 2 people today. I know I didn't do the class at the regularly scheduled time. Hopefully you'll watch it later on in the day. Anyhow, concentrations of ions can be multiplied by salts with multiple equivalents of ions. For example, what is the sodium concentration made by dissolving sodium chloride, sodium sulfate, and sodium phosphate to make 0.1 molar solutions of each salt? All right, so let's look at how that works out. Question: what is the sodium ion concentration in 0.1 molar solutions of NaCl, sodium sulfate, and sodium phosphate? So 0.1 molar NaCl gives a sodium ion concentration. Notice when I put a square bracket around the symbol, it means concentration of. So this means concentration of sodium ion. It'll be 0.1 molar. A 0.1 molar solution of sodium sulfate gives a sodium ion concentration of 0.2 molar, because, when that dissociates, it releases 2 sodium ions. And if you have a 0.1 molar solution of sodium phosphate, then your sodium ion concentration will equal 0.3 molar. Which brings us to the next question in the text. This is the practice example on page 147. It asks, potassium carbonate, K2CO3, at a concentration of 0.015 molar gives 0.03 molar potassium concentration because every mole of potassium carbonate yields 2 equivalents of potassium. I just realized I made a spelling mistake there. All right, so if you have 0.015 molar potassium carbonate, then the potassium concentration is equal to 0.015 molar times 2 moles of potassium ions for every 1 mole of potassium carbonate. If you really want to be, a stickler about it, all right, so that gives you a potassium ion concentration equal to 0.030 moles per liter. On practice example on page 148, gives us a little problem to do. Wondering, are you seeing this clearly? Yeah, I'm thinking you are, yeah. Practice example on page 148 of chapter 4. The question asks, how many grams of sodium sulfate are there in 15 milliliters of 0.5 molar sodium sulfate? So it's asking, there's 15 milliliters of sodium sulfate at a concentration of 0.05 molar. And it's asking you how many grams of sodium sulfate. We're going to use the number of moles is equal to the molarity times the volume. The molarity is 0.5 molar. You can say that as moles per liter. The volume of it is 15 1,000ths of a liter. So if you multiply that out, you get 0.0075 moles of sodium sulfate. Multiply that by the molar mass of sodium sulfate, which is given by 2 times the molar mass of sodium, 98977, plus sulfur, which is 32.065 grams per mole, plus 4 times oxygen, which is 15.394 grams per mole. So what you get is basically 0.0075 moles times this all added up, which is 142.04214 grams per mole, gives you 1.06531605 grams of sodium sulfate. Ran out of room there, sorry. And you get 1.1 grams when you report it to the correct number of sig figs. You're only allowed 2 sig figs, so you have to round up. So you get 1.1 grams of sodium sulfate. By the way, the official start of class will be April 6th. So by April 6th, you should be reporting and watching this video and doing what you're told so as to fulfill the curriculum requirements. So for the time being, we're just doing some review. We're getting you used to the idea of watching a video. But you should take this just as seriously as coming to class because we're trying to provide you with an education. So it's up to you to also take responsibility for that aspect of it, which is in your control. We have the technology, we have the means, let's use it in the best way possible. Part B of this question on page 148 asks, how many milliliters of 0.5 molar sodium sulfate solution are needed to provide 0.038 moles of this salt? So, how many milliliters to provide 0.038 moles sodium sulfate from a 0.5 molar solution? So we're looking for a volume. So we're going to use this version of the equation. Volume is equal to the number of moles divided by the molarity. And so we enter the number of moles, 0.038 moles of sodium sulfate. You can write, instead of writing the whole word mole, you can leave out the E. And it's MOL, it's an abbreviation. That's just as well. And then the concentration is 0.5 molar of sodium sulfate. If you write just a big M, it's like saying moles per liter. That works out to 0.076 liters of the solution. We're going to multiply that by 1,000 milliliters per liter, which you should know is the conversion factor from liters to milliliters, and your answer, final answer, will be 76 milliliters of that solution is necessary. The next idea I'm going to explore is dilution. Dilution is when a solvent is added to a solution. Dilution lowers the concentration of the solute. In a dilution, the amount of solute remains the same. It is simply spread out over more solvent. So when you do a dilution, you can use the same formula as, well, when we use titrations and dilutions, we can use the same formula. And it actually also looks like the formula for transfer of momentum. It's a simple formula. It goes M1V1 equals M2V2. Mind you, the variables mean different things than they do in the physics equation. But for dilutions and titrations, you can use this formula to do the calculations. M1V1 is equal to M2V2, and it also equals N, because when you dilute a solution, you're adding solvent. You're not actually changing the amount of solute. So the amount of solute stays the same. It's constant. It's as though, you know, you can have an espresso, or if you add more water to it, it'll be like a regular coffee, but the amount of caffeine you're getting is the same. You're just spreading it through more water. So M1 equals molarity before, V1 equals volume before, M2 is equal to molarity after, the dilution that is, and V2 equals the molarity after, equals the volume after the dilution, and N equals the number of moles. Of solute. On the question, give it some thought, on page 150 of the textbook, it says, how is the molarity of a 0.5 molar KBr solution changed when water is added to double its volume? Well, if you double the volume, you halve the concentration. So concentration goes from 0.5 to 0.25. Pretty easy. Let's do practice example on page 151 together. A. Part A says, what volume of 2.5 molar lead 2 nitrate contains 0.05 moles of lead ions of plumbus? We're going to use, because they're asking for volume, we're going to use V equals N over M. The stock solution weighs 0.05. It has 0.05 moles. No, what we're looking for is 0.05 moles, sorry. And the stock solution has a concentration of 2.5 moles per liter. All right, so the volume you're going to need to get you that amount of moles is 0.02 liters. We'll multiply that by 1,000 milliliters per liter, so you get 20 milliliters as your final answer. In part 2 of the question, part B, I mean, it says how many milliliters of 5 molar potassium dichromate solution must be diluted to prepare 250 milliliters of 0.1 molar solution. So in this case, we're going to use the dilution formula. M1V1 equals M2V2. You have 5.0 molar of the original concentration of the solution. They say how much volume of it do you need to prepare a 0.1 molar solution and 250 milliliters of it. Now mind you, for volume you could enter liters or milliliters or any other unit you want. Just remember, you got to use the same unit before and after. If you change the units, like if you put liters here and milliliters there, you're going to get the wrong answer, guaranteed. Okay? You got to use the same unit in both the V1 and the V2. It doesn't matter what the unit of volume is, it's just got to be consistent. Okay, so you get V1 is going to equal to 0.1 molar times 250 milliliters divided by 5.0 molar. The volume ends up being 5 milliliters of the original stock solution. Part C is next. Part C, it asks, if 10 milliliters of a 10 molar stock solution of sodium hydroxide is diluted to 250 mLs, what is the concentration of the resulting stock solution? All right, so we're going to get M1V1 equals M2V2. So 10.0 molar times 10 ml equals M2 times 250 ml. So M2 is going to be equal to, you take this and transpose it over there. You can do that yourself. Final answer is 0.4 molar. So, I know students love formulas. I don't like using formulas, but I'll make it easy for you. It's better for you to understand what's going on and with the units than to memorize formulas. But there's basically 3 sort of formulas you keep coming back to if you're really a lover of formulas. So I'll show you what they are. You'll find this on page 146 and page 151 of your text. 10th edition of brown or white cover textbook. First of all, if you want to go from grams to moles, you got to divide by molar mass. If you want to go from moles to grams, you got to multiply by molar mass. When you go to moles of one substance to moles of another substance, you must always take into account the stoichiometry of the reaction. And of course, the same thing applies on this side. You can do, you know, if you want to go to grams, you're going to multiply by molar mass. You want to go from grams to moles. Sorry, drew the arrows the wrong way. Okay, and then you should also remember that molarity is equal to the number of moles per liter, and M1V1 equals M2V2. So those three formulas, or sort of little mini algorithms, basically will get you through all of chapter 3 and 4 of this text. Okay, the one that we use all through grade 11 and 12. Let's look at practice example on page 152, where we look at solution stoichiometry and chemical analysis. In the first practice exercise, part A, it says, how many grams of sodium hydroxide are needed to neutralize 20 milliliters of 0.5 molar sulfuric acid solution? Remember that in neutralization reactions, the moles of H plus will have to equal the moles of OH minus. This fact makes it possible to use the dilution formula for titration calculation. So the dilution formula, M1V1 equals M2V2, remember, both of those quantities equal N, the number of moles, because the solute remains the same. Well, in a titration reaction, because equimolar amounts of H plus are reacting with OH minus, it's essentially the same concept as a dilution. There's the same amount of solute neutralizing the same amount of another solute. So you can use that idea to figure out the titration. So in part A, we're going to use N. Practice example on page 152A. It is appropriate to use N equals M1V1 equals M2V2. In this particular case, they give you a quantity how many grams of NaOH are needed to neutralize 20 milliliters of 0.15. So to get to grams of NaOH, you have to get to moles of NaOH first. So that's what we're going to do. So they don't actually give you the molarity of the NaOH, they just give you that they want a certain amount of grams NaOH. Well, that's part of the formula that's going to help us to get the grams of NaOH. So N equals M2V2, and that means that N is equal to 0.15 moles per liter times the volume of solution used, which was 21 thousandths of a liter, times the stoichiometric coefficient. Remember that sulfuric acid is a diprotic acid, so it takes twice as many moles of sodium hydroxide to neutralize a certain amount of sulfuric acid. So that's why we're going to say 2 moles of H plus is produced for every 1 mole of H2SO4. If you forget that stoichiometric coefficient, you're going to get the wrong answer. So that works out to 0.006 moles of NaOH needed. So we're going to multiply that by the molar mass of NaOH, which is made up of sodium, 22.98977 grams per mole, plus the oxygen, which is 15.394 grams per mole, plus the hydrogen, which is 1.00794 grams per mole. Add that all together, and you get 0.006 moles times 39.9971 grams per mole. Moles cancel, and you'll get, after sig figs, that you need 0.240 grams of NaOH. That's your final answer. In part B of page 152 practice exercise, First of all, let's show the chemical equation of what we're solving. We're showing that plumbous nitrate is reacting with hydrochloric acid to give you plumbous chloride, which is a precipitate, and then you're going to get a byproduct. You get nitric acid as the byproduct. So it's a 1 to 2 stoichiometry. For every 1 mole of plumbous nitrate, you need 2 moles of hydrochloric acid to precipitate it. We're told that there's 0.1 moles of plumbous nitrate and that the concentration of the acid is 0.500 molar. So because N is equal to mV, and you have 0.1 moles of this stuff, and you need 2 moles of HCl for every 1 mole of plumbous nitrate, then you're going to need 0.2 moles of HCl. So we're going to say 0.2 moles is equal to the 0.5 molar HCl solution times X number of liters to get the correct amount of moles. Transpose that 0.5, you get 0.200 moles divided by 0.500 moles per liter, and you'll get 0.4 liters. Multiply that by 1,000 milliliters per liter, you get an answer of 400 milliliters as your final answer. And that's done. If you want to practice some of this stuff, you can, well, you know what? I recommend you try redoing the questions that I just showed you. All right? Copy down the question and see if you can arrive at my answers without actually looking at the video or my notes. By the way, you saw that I gave you all my notes. I showed you all my notes. You could just freeze frame and copy them off the screen. I recommend you do that because just copying it once is going to help you learn the material. And I will see you tomorrow.